Hi everybody. Today we're going to be talking about the normal distribution and we will be using OurGuru to make our calculations. So what is a normal distribution? We've talked about a symmetric bell-shaped distribution in the past, such as with standardized test scores. So what does it mean to have a symmetric bell-shaped distribution? So if we had people take a standardized test score, and then if we counted how many people got each score and built a histogram, specifically a relative frequency histogram, the histogram might look something like this. And so it is symmetric with the higher bars in the middle and the lower bars on either side, the right and left. Now, if the boxes got thinner and thinner and we measured the scores more finely, then the histogram would start to look like a smooth curve like the one on the right. So if you look, the shape of this one over here is making a similar shape to the one right there. So these are some qualities like these test scores, or there are some qualities like these test scores that have a natural distribution like this, and we call that the normal distribution. And we're going to really dig into the properties of this normal distribution in this lesson. So here we have a bell-shaped curve, also known as a normal distribution. It is just like a probability distribution. This density curve tells us how likely a given outcome is based on the height of the density curve at that point. So, for instance, the SAT verbal score is 508, which also happens to be the mean because it's in the middle. And so if you'll notice, the mean and the median in the center, and the mode, because it's the one that occurs the most, it's the highest, is in the center, and then all the other scores fall to the right and left. So the most common score, again, the mean, is 508, and that is the most likely result to occur because, again, it's the mode, it's the one that occurs the most. And so not only that, but the distribution gives us a precise description of how the scores are clustered around the center. And so if you'll recall, we learned about that earlier with the empirical rule. So two parameters define a particular normal distribution: the mean, the center, and a standard deviation. So I'm going to enlarge this so you can really see here. So over here, it looks a little blurry, but over here you'll see the mean is 0 for the first three and then -2 for the last one. And on the right, you'll see varying. These are actually variances, so the standard deviation squared of 0.2, 1, 5, and 0.5, and then we have various colored lines here. So first, you'll notice that when the mean is 0 and the variance is 0.2, it is this curve here. So the variance of 0.2, it has a smaller spread. The mean is in the center, it's 0. Now, keeping with the mean of 0, but if you change the spread to 1, it's more spread out. Let's look at this red one. See how the difference is? The top of the graph has gone down, and it is definitely a wider graph. Keeping it at 0, but then having the variance go out all the way to 5. Look at that. That's this yellowish curve. Look how spread out that is. Now, what happens if you change the mean? So if the mean, basically that changes where the center is. So we move it over to the left to the -2, and there's that particular graph. So you can see kind of how the mean affects where the center is, and the variance or the standard deviation affects how spread out the normal distribution is. So if you'll recall the empirical rule, we studied that a while back. The mean is in the center, and these are properties for any distribution that is normal, that is symmetric. So, and what it says, if you go up 1 standard deviation and down 1 standard deviation, that's approximately 68% of the data. If you go up 2 standard deviations and down 2 standard deviations, that's approximately 95% of the data. And if you go down 3 and up 3, That's approximately 99.7% of the data. So that is a review. So using that as a review, the intelligence quotient. IQ is normally distributed with a mean of 100 and a standard deviation of 16. Use empirical rule to find the data that is within 1, 2, and 3 standard deviations of the mean. So if you'll recall, when we did things like this, we went ahead and we drew out a curve. And then we labeled the mean as 100. And we can do this because they say it's normally distributed. So this is the shape. And so then what we would do is we would add the standard deviation, which is 16. We would add it 3 times. So if you add it once, you get 116. Twice would be 132. And 3 times would be 148. That's adding 16 3 times. Then if we were to subtract 16 3 times from the mean, so subtract 16, I'm tripping over my words, subtract 16, we would get 16 from 100 is 84, and 68, I believe. And if you subtracted it one more time, you would get 52. So let's see, 84 and 16 is 100, 68 plus 16. I believe that's right. I believe my mathematics is correct. Anyway, so if we go out 1 standard deviation each way, that's approximately 68% of the data. So approximately 68% of the data is right there. And then if we go out 2 each way, here to here, from 68 to 132, that's approximately 95% of the data. And if we go out 3 each way, that's approximately 99.7% of the data. All right. So we'll look at one more. Suppose you know that the price paid for cars are normally distributed with a mean of 17,000 and a standard deviation of 500. Use the 68, 95, 99.7 rule, empirical rule, to find the percentage of buyers who paid less than 16,000. Okay, so let's draw our curve and label. So let's see, 17,000 is in the middle, and the standard deviation is 500. So these should be actually pretty easy to add each way. So if we went up 1, that'd be 17,500. 2 would be 18,000. And then 3 would be 18,500. Let me extend this a little. And then if we were to go out the other way, if we subtracted 500 each time, we would get 16,500 minus 500 would be 16,000, which is actually what we're interested in, but I'll go ahead and go with one more, 15,500. All right, so just based off of what we know, I know between these two is 68%, and then between 16,000 and 18,000 is 95%, and between 15,500 and 18,500 you have 99.7%. However, those don't necessarily help us. Well, they do help us, but they don't give us the overall answer, because we want to know who paid the percent of buyers that paid less than 16,000. 16,000 is here. It is attached to the 95%, but also attached to this 18,000 right there. But what we want to find is the percentage of buyers that paid less than 16,000. So less than 16,000 would be this. So that's what we want to find. We want to find that percentage. We don't want to find a percentage in between. So several ways to look at this. One, the whole thing the whole curve has 100% of the data within that curve. So I know the whole curve is 100%. I know that if I split the curve in half, it's symmetric, so 50% on either side. So let's look at it this way. I think this might be the easiest way. What do I know about the 16,000? I know that if I look at this between 16,000 and 18,000, I know that there is 95% of the data. So I'm going to shade that and label that so I can see this visually. This is 95% right there. I also know that this whole thing is 100%, right? So if I took that 95% out, if I covered up this 95% in the middle, so we just see if this will let me do this. It's actually not letting me do it. It's too transparent. But you can see what I was doing. Like if you were trying to take out this middle 95%, what would be left would be what is over here on the left and what is over here on the right. Let me just go ahead and cut this out since that is not working. So anyway, so if we were to take out the 95% in the middle, that would leave 100% minus 95% would leave 5% left over. So between this side and this side, those two should add up to be, so the left side plus the right side should add up to be 5%. So because it's symmetric, the left side and the right side should be equal. So if I divide 5% in half by 2, I get 2.5% on each side. So you get 2.5% over here and 2.5% over here. So again, find the percentage of buyers who paid less than 16,000 right there, 2.5%. So again, we knew that 16,000 was part of the 95% between 16,000 and 18,000. It was 95% of the data because of an empirical rule. And if we take that out, that leaves the left side of the right side, which would be 5% left over. Divide that in half, and that gives you the amount that paid less than 16,000. So empirical rule is great. You can use it to find different percentages. You can use it to find different boundaries, but we're limited to those boundaries that are attached to the 68, 95, and 99.7% of the data, the 1, 2, and 3 standard deviations each way. So what if we want to know points that don't happen to be exactly 1, 2, or 3 standard deviations from the mean? So this is where we recall some vocabulary from the past. So the first one is z-score. And a z-score we had a formula for, but specifically what did that formula find? It found the number of standard deviations a data point is above or below the mean. And so we can use these z-scores to describe the probability that a randomly chosen data point falls within a certain range. So next comes the area under the normal curve. So that is actually what we were illustrating here. So we knew that 95% of the data fell between 16,000 and 18,000. But what we didn't discuss is that this area that I've shaded here, between these boundaries, between 16,000 and 18,000, that area is 0.95. It matches up with the percentage of buyers who paid between 16,000 and 18,000, right? So if we find the area under the curve between 2 points, A and B, then that represents the proportion of data points between A and B. So again, if I wanted to know what is the area between 16,000 and 18,000, it would be 0.95, and 0.95 would also represent the proportion who paid between those two numbers. So when you find the area, you are finding the proportion, and you also find the probability that a randomly chosen data point is in that range. So if I went back up here, the probability that if I were to randomly choose a buyer, the probability that the buyer paid between 16,000 and 18,000 would be 0.95. So why do we discuss all of that? Because we can find area, which there's a way to use technology to find the area under the curve between any 2 points, not just 2 points that are 1, 2, and 3 standard deviations above and below the mean. You can do it with any points at all. And if you find that area, then you have found both the proportion of points between those two data values, and you've also found the probability that a randomly chosen data point is in that range. One more thing, this is important to note for later. There is a special normal curve called a standard normal curve, and what's special about it, the mean is 0 and the standard deviation is 1, which means a z-score converts a non-standard normal distribution to a standard one. So basically what that means is if you were to convert all the data values in a data set to z-scores and you were to graph them in a histogram, you would end up with a standard normal curve. And that standard normal curve would have a mean, it would have a mean of 0 and a standard deviation of 1. Okay, so we want to figure out how to do this with technology. So again, what we're doing is we're not limiting ourselves to 1, 2, and 3 standard deviations like we did with empirical rule. What we're saying is if I wanted to know what is the proportion of data values between a half a standard deviation below and 2 standard deviations above, I could find that quickly and easily with technology, specifically OurGuru, rather than trying to use empirical rule. And again, empirical rule is great. It's awesome. It tells us different properties that are special about our data sets, but it is limited. So how do we use OurGuru? So the great thing, number one, about this is you don't have to enter a data set. That's one of the tedious things that we've had to do in the past. We found mean and median and 5-number summaries and all of that fun stuff. But when we're finding normal distribution, probabilities, and proportions, we actually don't have to enter a data set. We have to enter some data, but not an entire data set. So that's kind of cool. So the first thing that you're going to do is if they give you a data set that is normally distributed and they ask you what proportion of data falls between these two values, or what is the probability that if chosen, you'll choose something that falls between these two data values, then you're going to click on the probability simulations tab. So on the left hand side, you have the different tabs. You have data, you have plots, you have analytics. Next, you have probability simulation. We're going to click on that now. And there's a probability drop down right there. And you are going to click on that, and then the drop down, you're going to choose probability calculator. That's what you are going to choose, probability calculator. And then once you click on it, a menu will pop out to the right and it will say continuous and discrete. So this is similar to how we found binomial probabilities when we chose discrete, except now we're going to choose continuous. So when we're doing normal distribution probabilities and proportions, we're going to choose continuous. So once you do this, a box will pop up, and if they give you values and you're looking for the proportion or the probability, you're going to keep it at values to probability. If they're asking for the reverse, you would click on probability to values. But for now, let's just look at values to probability. You are going to make sure your distribution says normal, and then you're going to enter your mean and your standard deviation. If it's a standard normal curve, the mean will be 0 and the standard deviation is 1. But if they give you a different mean and a different standard deviation, you want to definitely put that in. And then here they give you options of below, above. It just depends on, like if we were doing this one up here and we said who paid less than 16,000, percentage that paid less than 16,000, we would put below here and then 16,000. And then if you want to see the graph, which I think is always a good thing, you would click the graph and then you would click the preview button. And that's basically it. So we can do all of these up here where we drew all of this out. We could answer all of these questions quickly with OurGuru, which is pretty awesome. Okay, so finding the normal probabilities with OurGuru. So here's just an example of when you click on the graph, this is what it shows you. Okay, it'll say, it'll tell you the mean and the standard deviation up here, right? And then it'll say the probability. They always put it as a probability. The probability that it's, and in this case, less than or equal to 1.5. So this here found the probability that, or the proportion that was below 1.5 when the mean is 0 and the standard deviation is 1 specifically. And you can see it is shaded. This is the amount that's below 1.5. So we've got 1.5 highlighted here, and then anything to the left, anything less than that is shaded. And so you can see that the proportion, the area of this graph that is less than 1.5 is 0.9332. That's right there. That also means that the proportion of the population that is less than 1.5 is 0.9332, which is 93.32%. And it also means that if chosen randomly from the population, the probability that you would choose something less than 1.5 would also be 0.9332. But that's what that would look like. If you didn't click graph, it would just put the probability or the proportion in the calculator window, and you just wouldn't see the graph. So let's look and see how we're going to use these. The average length of pregnancy is 272 days, and the standard deviation is 9 days. Find the probability that a randomly chosen pregnancy will last less than 252 days. So I find it good practice to draw out a normal curve. Now, normally what they would say is, and that's missing here, is that pregnancy has a normal distribution. So we're going to assume that's missing here. We're going to assume it's a normal distribution. Normally it would say that though. So assuming that it's a normal distribution, and we know that the average pregnancy length is 272 days with a standard deviation of 9, I would label 272 in the middle. And you do not have to do any calculations with the 9, like filling out the curve like we did with empirical rule. This is all you do. You kind of sketch it out for yourself. And then it says, find the probability that a randomly chosen pregnancy will last less than 252 days. So what I encourage you to do is to kind of estimate, where would 252 fall in comparison to the 279. I'm sorry, and I just noticed I wrote 279. It should be 272. Sorry about that. Okay, so 252 would fall somewhere to the left of 272, and this doesn't have to be perfect. Okay, and then we want to find the probability that a randomly chosen pregnancy will last less than 252 days. So less would be to the left. So that would be where any shading would go. And so what's happening here is that we want to find the probability that a randomly chosen pregnancy will last less than 252 days. So if you will recall, up here we said to find that, that's the same thing as the area under the normal curve associated with those values. So the area under the normal curve that's less than 252, this area here is the same thing as the probability that a randomly chosen pregnancy will last less than 252 days. So let's use OurGuru to set this up. Okay. So I have OurGuru up. So you're going to click on probability simulation and click on the probability drop down and choose the first option, probability calculator. In the menu that pops up to the right, you're going to choose continuous and a new box will pop up. You can name your calculation on the left if you want to. I usually don't bother with that. They gave us values and they're asking for the probability. Another thing they could ask you for is a proportion. If they give you values and they're asking for a proportion, because you'll remember the area represents both probability and proportion, right? Okay, so distribution should be normal. There are other options, but we're going to keep it normal. And the mean, you're going to enter that in. So the mean length of pregnancy is 272 days. And the standard deviation is 9. See how easy that is? You just type in the mean, type in the standard deviation. And we want to know the probability that it lasts less than. So less than would be below. So I'm going to keep it at below 252 days. Now, if I don't hit graph, I just want to show you, if I hit the preview, you'll see I get 0.013134. And so when you look at it this way, it usually goes out pretty far. So this helps you when you're doing homework or whatever, and it says round to, let's say, the 4th or 5th decimal place. You can definitely see that here. Let's see what it looks like when you graph it. Now, I do like to do the graph. And the reason is because it really helps me to check. I can see the direction that the shading happened. So I can see that the shading is happening to the left of 252. And then if you look above it, you can see it says PX that's less than or equal to 252. So we're saying that it's less than 252 would be 0.01313. And so I believe that the numbers didn't go out quite as far for the probability here for rounding purposes as it did when we didn't graph it. So, but it does still go out pretty far. But the great thing about this, again, is that you can see the shading to the left. Yay! And I know that's the direction it was supposed to be shaded. And so I can check the direction of the shading. I can also check here where it says the mean is 272 and the standard deviation is 9, and I want it to be less than 252 to make sure that I've entered everything incorrectly. So I have entered it incorrectly, and I get 0.0131. And we just put that down. So that is this area here, which represents the probability that it lasts less than 252. So let's do the opposite. Let's do what's the probability that a randomly chosen pregnancy will last more than 252. So we want to shade to the right. So let's go, and I can just go to basics, and I can just change this to above 252. And I'm going to leave the mean and the standard deviation the same. I mean, I could go back and hit probability calculator, continuous, and then enter everything in fresh. But because it's using the same mean and standard deviation, I just chose to use the same calculator, click on basics, and make my adjustments. So preview button. Now I can see I've shaded to the right of 252, and that is 0.9869. So I do want to show you something real quick. So I just want to show you, if I were to draw this here, and then here's your 252. And then the area to the left we found was 0.0131, and to the right is 0.9869. Add those together. Add 0.0131 plus 0.9869. Add those two together, and you will get 1, or 100%, right? And so that should make sense. The area to the left of 252 plus the area to the right of 252 should encompass the area of the entire curve, and so that should be 100% or 1. All right, so let's do a different one. A randomly chosen pregnancy will last between 252 and 298 days. So again, 272 is in the middle, and then 252 is somewhere over here on the left. Again, it doesn't have to be perfect, just estimate it, eyeball it. 298 is somewhere over here. And we want to find the probability that a randomly chosen pregnancy will last between 252 and 298 days. So what we're finding to find that probability is the area between those two numbers. So let's go back to, I'll just start from the beginning just to remind everybody how the whole thing works. Let me close this one off. Don't say. Go to probability simulation, probability calculator, continuous, values to probability, keep it normal. The standard deviation, the mean was 272. And the standard deviation was 9. And we're seeing if it's between. So we would click between, and then lower tail you would put 252. And upper tail we would put 298. And then graph and preview, and you can see the shading is in between, and the area is 0.9849. So it is that quick. The calculations are that quick. Okay, so let's look at another example, blood pressure. The Centers of Disease Control and Prevention reported that diastolic blood pressures of adult women in the U.S. are approximately normally distributed with a mean of 80.5 and a standard deviation of 9.9. So this one does include the wording like it's supposed to. They do tell us that it's approximately normally distributed with a mean of 80.5 and a standard deviation of 9.9. What proportion of women have blood pressures lower than 70? So they ask what proportion. So again, the area under the curve gives us two things. It gives us the probability, if randomly chosen, that it falls between the 2 points that you're finding the area for, and it also finds the proportion of the population that's between the 2 points. So to find proportion, to find probability, we're going to find the area. And to find the area, we're going to use the probability calculator in OurGuru. So again, I like to draw this out first. We have a normal distribution for blood pressures. The mean is 80.5. And we want to know what proportion of women have blood pressures lower than 70. So 70 is somewhere to the left. Lower would be shaded this way. So let's go to our probability simulation calculator and click on the probability simulation tab. Click on probability drop down, probability calculator, click continuous. Normal distribution, we're going values to probability. The mean was 80.5. And the standard deviation was 9.9. And we want to know the probability, or I'm sorry, the proportion that is below 70. And we can see it is shading below 70. I put in the correct mean and standard deviation, and we get a proportion of 0.1444. That's the area shaded. All right, next, find the probability of a randomly chosen woman would have blood pressures between 75 and 90. So again, 80.5 is in the middle, 75 is somewhere to the left, 90 is somewhere to the right. I don't know how far left and right each way. You're just kind of drawing this for yourself so you can kind of make sure you know what you're trying to find. So we're going between 75 and 90. So I'm just going to keep the same calculator, click on basics, because the mean and the standard deviation isn't changing. What it is going to change is that I want the area between, and it's between 75 and 90. And then we click preview, and you can see between 75 and 90, and it looks like the probability is 0.5421. All right, so again, super quick, super easy to do these problems. A diastolic blood pressure greater than 90 is classified as hypertension, high blood pressure. What proportion of women have hypertension? So what proportion of women have hypertension? So you have hypertension if your diastolic blood pressure is above 90. So any above here. So let's just quickly go back and change it to above 90. And we look at it and we get 16.86%. So a proportion of 0.1686, which is again the same as 16.86% of women have hypertension according to this graph. Okay, and all of those questions that we just did, we were finding the proportion or the probability by finding the area, given boundaries, given values. So we chose values to probability in the calculator. But what if we were to turn the question around, and instead of asking what percentage of people fall within a certain range, we could ask the range that corresponds to a given percentage or proportion or probability. So to do this, we would actually click on the probability to values instead. So what kind of things would they ask for this? They would ask for maybe percentiles or quartiles like Q1 or Q3, and we would find this without this. Now, keep in mind, you wouldn't necessarily know the data set, so you couldn't find the quartiles the old-fashioned way by finding the 5-number summary. If they just gave you the mean and the standard deviation and told you it was a normal distribution, and then asked you to find a specific quartile or percentile, you could use this probability calculator to do that in OurGuru, which is actually pretty nice. Anytime they ask for a percentile, anytime they ask for a quartile, anytime they ask for a percentage that corresponds to a boundary, anytime they ask for a boundary that corresponds to an area or a percentage, there we go. I think I said it right that time. You would do the opposite. Instead of clicking values to probability, you would click probability to values. So how do we do that? All right, it's very similar to before. You'd open the continuous probability calculator by clicking probability simulations tab, the probability calculator, choosing continuous. But this time you would change the top from values to probability to make sure it says probability to values. And then it is going to ask for the distribution is normal. It'll ask for the mean and the standard deviation, but you'll notice this part here is going to change just ever so slightly. And so what we do is we may have to do a little bit of calculations depending on what they're asking, right? Basically what you have to do is you have to enter the particular area, which would be the probability or the proportion that they're giving you, to find the corresponding values, right? So let's get into that. Let's see how we do that. Just saying it out loud makes it sound a little bit confusing, but once we get to it, you'll see it's actually not so bad. So the part at the bottom where it says lower tail, it gives you the option for lower tail, upper tail, between tails, and outside of tails. And so basically what that means is it just depends on the probability or the proportion or the area that they give you. Where is that located? Are they giving you the area below the value they're looking for? Are they giving you the value above the value that you're looking for? Are they giving you the area in between the values you're looking for? And you choose accordingly and then have to put in that percentage. But again, it sounds a little complex, but it doesn't have to be. So let's look at what some of the questions will look like and then how we would do this. Okay, so just again, this is just a picture of showing you what it looks like once you find it. If you were finding the boundary for the lower 5%, when the mean is 0 and the standard deviation is 1, it would show the graph like this. So what it's shading is the area that is, this area here is 5%, and they are giving us the value that corresponds with that. You will also see that value right here. So it wouldn't be this one. This is the number that you're putting in, the 0.05. It would be this one here. That would be your answer. And that's what it looks like when it's graphed. All right, so cherry trees. Cherry trees in a certain orchard have heights that are normally distributed with a mean of 112 and a standard deviation of 14. What proportion of trees are more than 120? So that one is very similar to the questions we had before. And I'm just kind of drawing this out. More than 120, it would look something like this. So really quick, let's go and find that. I promise we are going to get to the ones where we do the new stuff, the probability to values. All right, so probability calculator, continuous, and then the mean was 120. And the standard deviation was, I'm sorry, the mean was not 120. The mean was 112, and the standard deviation was 14, and we want to know the probability that it's above 120. That's what we were looking for. And I did not click on the graph because we've done this already, so I just clicked the preview, and you can see it's 2839 if you round. And then the next question, oops. The next question says, what's the probability that a chosen tree is either less than 100 or more than 125? Oh, I do like this one because this one is actually pretty different. It says less than 100 or more than 125. So we're actually looking at those outside values there. So I'm going to go back here, instead of above, I'm going to put outside. So outside, the lower value is 100 and the upper value is 125. And look at this. I'm going to click graph so you can see the shading. So see, they've shaded on the outside. So less than 100, more than 125, and that probability is 0.3722, right? So it's pretty cool they can do that. Okay, so now moving back to the new type of question. It says, find the 27th percentile of the tree heights. So percentile is like a quartile, although quartiles, again, are specifically 25, 50, and 75%. So when we say 27th, it's similar to the 25th percentile, it's just two more. So what is a percentile? Again, basically what it means is, if I were to split the data at the boundary for the, in this case, the 27th percentile, whatever that number is, that number separates the data into the lower 27% from the upper 73%. So basically, when they say 27th percentile, what they're doing is they're giving the lower area, so the area to the left. They're saying below this boundary is 27% of the data, above it is 73%. So that actually means that you could do this two ways. You could do the probability calculator for a lower tail of 27% or an upper tail of 73%. So lower tail would be area to the left, upper tail would be area to the right. Now, because it just says 27th percentile in the problem, I think it's easier just to use the 27%. So let's see what that looks like in the calculator. So when they're asking for a percentile, they're asking for a boundary. I'm going to start from the beginning just so that you can see it. So I'm going to go to probability simulation, click on probability, and then probability calculator and continuous. But because they're asking for a percentile, they're asking for a boundary. When they ask for a percentile, they're giving me the percent or the probability. So they're giving me the probability, and I want to find the value. So click probability to values. Normal distribution. The mean was 112, and the standard deviation was 14. And so what they did when they gave us the percentile is they gave us the lower tail. So you have options lower tail, upper tail, between tails, outside tails. Lower tail is when they give you the area to the left or the lower. Upper tail is when they give you the area to the right or above. Between, obviously, is when they give you the area between the two. And then outside is when they give you the area on either side. So we're going to choose lower, and we're going to put in the area to the left, which is 27%. So here's the thing. You got to put it in as a decimal. 0.27, like that. I'm going to hit graph so you can see what it looks like, and you hit the preview button. And so they're saying that the area is 0.27 right here. The value is 103.4. Now, depending on how they want you to round, if you look here, it only goes out to 1 decimal place. If you look below here, they went out 2. If that's not far enough, okay, so I'm going to go ahead and write that down. It's 103.42. So I've written it on the other screen. But I'm going to go back to basics, and I'm going to uncheck the graph button and then hit preview. And it looks like it only rounds to 2 decimal places here as well. Sometimes it might go a little bit further if you unclick the graph and just use the calculator. So in this case, it doesn't matter, but if it ever doesn't go out far enough, that might be a way to check to see if it'll calculate it a little bit further for you. Anyway, so there we have it. This number here, the number that separates the lower 27% from the upper 73 is 103.42. Oh, you can't see that. Sorry. Let me go back here. So the number that separates the lower, sorry about that, the lower 27% from the upper 73% is this number right here, 103.42. There we go. There's your visual. So again, anytime they ask for a percentile, anytime they ask for a quartile, if they ask for a boundary, a cutoff number, anything like that, you want to go from probability to values. Okay, so you want to go from values to probability. If they give you 2 boundaries and they're asking for the proportion or the probability, they could also ask you for percent, which is different than the word percentile. So probability, proportion, percent, you're going to go from values to probability. Any kind of boundary, again, you're going to go from probability to values. All right, so let's look at a couple more. Recall the average length of pregnancy is 272 days and a standard deviation of 9 days, and assuming that it is normally distributed. Find the 65th percentile. So the 65th percentile, all right, so 272 is in the middle. The 65th percentile separates the lower 65% from the upper, what would it be, 35%? All right, so we're going to do a lower tail because this here, that's the lower tail. This is the upper right there. That's the upper on the right, the lower's on the left. They gave us the lower tail when they gave us the 65th percentile as our number. So going back here, we are going to do probability calculator, continuous. We're going from probability to values. Mean is 272 with a standard deviation of 9. And we're choosing lower tail. And you have to put in as a decimal. The lower tail is 0.65. And it looks like we get 275.47. All right, so that is this number right there that separates that. All right, so it says find the, now look at the questioning. So the first one said, what is the 65th percentile? The next one says find the boundary. So a boundary is a value, and they're giving us the percentage. All right, so 272 is in the middle. The upper 25%, so the top 25% of the data falls on the right. So they're asking us for the boundary for the top 25%. They're asking us for this value here, right there. That's what they're asking for. So this time, did they give us the lower tail? No, they gave us the upper tail. So they gave us the upper. So we're going to go here, and I'm just going to go back to basics and just adjust. The mean is 272, standard deviation is 9. We're going probability to values. This time they gave us the upper tail. So click upper tail, and again, it has to go in as a decimal, not a percent, 0.25. And you can see it shaded the upper 25%, and it looks like we get 278.07. 278.07. All right, so it says find the boundaries, plural, for the middle 80%. So what they're saying is 272 is in the middle, and they want us to find the boundaries for this center section, this 80% here. So the lower boundary and the upper, they want us to find two boundaries. The middle is 80%. Okay, so if they give us the left boundary, or the lower tail, the upper tail, it's not a big deal. It's actually pretty easy and quick to do. When they give you an in-between, they actually are going to ask you for two tails. They're going to actually ask you for the upper and the lower tail. So which means you have to do a little bit of calculations ahead of time, which is not bad. It helps you to really understand this curve. If 80 is in the middle, right here, we want to know what is on either side. If 80 is in the middle, how much is here and how much is here? So remember, the whole thing is 100. So if I take out this 80, that leaves 20 between these two sides. And if I split that 20 up, that is 10% and 10% on either side. So again, if they give you a middle, to find the lower and the upper tails, do 100% minus the middle, and then divide that whole thing in half by 2, right? So and that would give us 10 and 10. So we have 100 minus 80 is 20, and 20 divided by 2 equals 10. Okay, so why do we need all of that? So when we are finding the boundaries, it'll find both at the same time. Go back to basics and change it to between. And notice, instead of saying between, instead of having just one value in the middle, they want you to give the lower tail and the upper tail. So again, the area to the left of the middle and the area to the right of the middle. So the area to the left of the middle is 0.10, and the area to the right is also 0.10. So you just put in the area on either side and preview, and you can see that the middle 80% is, so if you look what it says here. I just want to show you, and you can just double check. So it says, the area to the left is, hopefully you can see my mouse, is 0.1, and the area to the right is 0.1. But look, it gives you the area in between the two is 0.8, which is 80%. So you've entered it right. But then if you look at the bottom, you can see the two values. The left boundary is 260.47. and the right boundary is 283.53. So very quick. All of these calculations are very, very quick. It's nice. You don't have to put in a whole data set. You just need the mean, the median, and either the lower or the upper boundary, or you need the lower or the upper tails, basically, is what you need. But that is basically it. That is all there is to this section. So the only other thing that I would say is anytime they ask for, let's say, a z-score boundary, that means they're using that standard normal curve. And just remember, for the standard normal curve, the mean is 0 and the standard deviation is 1. but everything else, all the calculations are exactly the same. So that's all I have for you in this section. If you have questions, please let me know.